All right, let's do the side angle side case. And again, if you try law of sines, you're going to have too many variables with not enough equations. And so law of cosines is going to be the one you're going to want to do. And if you have an angle trapped between two sides, then obviously the cosine of that angle has to be what's in a formula. So what that means is, I guess I'm offline, that the side across from it, which is C, has to be what's on the outside for law of cosine. So if you have the 70, the C squared is the side across, okay? And then we have the other two sides, so 3 squared and 6 squared minus 2 times 3 times 6, cosine of 70. So just make sure you are on degrees, okay? And again, if you're going to type this in your calculator, you can just type it in. There's no variable over there. Do you see it? It's just like typing in a formula. So 3 squared plus 6 squared minus 2 times 3 times 6. And make sure you, number one, law of cosine. So make sure you use cosine. And then make sure you're in degrees. Okay. And then hit enter. Now that's the square. That's C squared. So I'm going to square root that. And if you want to do that from the beginning, you can. So, oh boy, I don't know what's going on there. Let's quit that. Okay, second square root, second answer. There we go. Okay, so you could just square root the whole thing to begin with. All right, so C after I square root is approximately, I'm going to do 717. Just if I round too much, you know, it's going to throw other things off. So I'm going to leave it for that for right now anyway. Okay, so that's my side. Now, if you want to do law of cosines again, you could do law of sines, whatever you want. I'm going to switch to law of sines. So sine of A over 3, sine of B over 6, and sine of, let's see, sine of 70 over 5.717. And if I round this to 5.7, it's just going to be off a lot. All right, I'm going to cross multiply. So I'm going to take the 6 times the sine, and I'm going to divide by the 5.717, and that's going to give me the sine of B, and then I'm going to have to do inverse sine to figure out the angle. So I am going to take 6 times, what do I have, sine of 70, enter, that's that much, divide by this guy, so divide by the 5.717, enter, and then that's what my ratio is. And so I am going to choose to do inverse sine to both sides. So second sine, second answer to get, what do I get? About angle B is about 80.5 degrees. Okay. And so that's angle B. So angle B is about what? What did I just get? 80.5 degrees. Side C we got here. So side C was about, I'll just put, I'm going to put 5.7 here, but again, we're going to use more of that. All right, so what do I need? I need the other angle. So angle A, I'm going to subtract from 180. And we could do law of cosines just to see, you know, how good we are here. 80.5. So what is that? 29.5 for that other one. All right, I'm going to pause. I'm going to do law of cosines to get something else here, and then we'll compare and see, you know, how good they are. Okay, just to show you, I'm going to do law of cosines a second time. So I did the 6 squared, okay, and then I did the 3 squared, and I used all of this because, again, rounding can really impact that. Minus 2 times the two sides. Cosine of angle B is across from that guy. Again, subtract these guys over and let your calculator do the math for you. All right, so get rid of the adding and subtracting part. So I got that. Multiply all this again on a calculator, divide both sides. That's the ratio that cosine is. And again, you're going to choose to do inverse cosine. It gives you angle B is 80.5. Okay. And then you can subtract from 180 to get what? Angle A, just like we did before. So either way works. The only thing is, again, if you only use like 5.7 in this, your angles, you know, might be off. So even though I would probably round side C to 5.7 in the formula, I'd probably use a few more decimal places just to not mess up my angles so much. All right. Okay, so those are kind of the two types of law of cosines. I want to show you area formulas next. And so let's look at these. If you have, let's go back to our first side, I don't know, my side one. All right, so let's look at that first side one. I had A was 3 inches, B was 6 inches, and C was 8 inches. Okay. If you have side, 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 Heron's formula is super cool. Okay. So first of all, you have to find S, and S is the semi-perimeter. So kind of like semicircle is half. So you add up and get the perimeter, but you take half of it. You're not averaging it. You're finding the semi-perimeter. All right. So again, if you're going to trust your calculator here, all right, again, you should be able to probably do that mentally, but you would take 3 plus 6 plus 8, enter, then divide that by 2 to get the semi-perimeter. So in this case, S is going to be 8.5, okay? And this formula is pretty easy to remember because the area is equal to, and you have the square root, and then you're going to write S 4 times. So S, 1, 2, 3, 4. You're going to have S 4 times. And then you're going to have subtract one side, subtract the other, and subtract the third. So there's an S in front, and then an S in each parenthesis subtracted from the side. Okay, and we're not going to prove it here. You can go online if you want to look at proofs of this theorem. So what you're going to do is you're going to write 8.5 4 times. So 8.5, 8.5, 8.5, 8.5. That's again the semi-perimeter. That's why it's an S. And then subtract each side. So the 3, the 6, and the 8. Okay. All right. So I'm going to pause. You pause and just type this in the calculator. We'll see if we can get the same answer. All right, I typed it in and I got an answer of 7.6 square inches or square inches, I guess. We can check that later using another method if we want, so we can see how that played out. All right. Okay, I'm going to pause. Well, yeah, let me pause to rewrite the next problem, and then we can go back and explore these more. All right, so what about if you have side, 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 okay, or side, angle, side. I don't know what I'm doing here, talking. All right, so on this one, what you can do is the area is half, and it's the two sides with the angle trapped between it with a sign here. So it could be like AB with sign of angle C, or it could be half BC with a sign, what angle's missing? A, or it could be half, what is this? AC sign of what? B? Okay, so any of those. And this one's, pretty easy to prove if we have time to. We'll see. All right, so basically what I want to do is I want to find the area, okay? And I have half, the two sides, 3, 6, and then I want the sine of 70 degrees. And again, just make sure you are in degrees. Okay, I'm going to pause. You type it in your calculator. I'll type it in. We'll compare. All right, I got 8.5 square inches. Okay, now with me, I usually, for Heron's formula, for whatever reason, sticks with me. Other formulas, maybe not so much. So on this one, if I'm like, well, what do I do if I forget? Well, remember, law of sines and law of cosines, which again, you're going to prove in a lab, are because you don't have a right triangle, right? But you can always make a right triangle because you can always cut it, right? So if it were me and I was given this problem on, say some grad school test to get in for my master's or whatever, I would be like, oh, shoot, I don't remember the formula. All right, well, that's fine. What I would do is I would just cut it and make it a right triangle, because then I know I can use maybe sine or cosine or tangent, or maybe I could do Pythagorean theorem, right? Like if I have a right triangle, I have more tools available. All right. So, and I'm going to call this H for height. So if I cut it, now the problem is the 3, you do not know how you cut that. That might be 1 and 2, 1.5, 1.5. It might be 0.75 and 2.25. Like this is not cutting that thing in half. It's not a bisector, okay? Only if you had an equilateral or an isosceles triangle. So we do not have that. So I'm going to do sine. So sine of 70 degrees is opposite over hypotenuse, which I do know, right? Because I know that side. So over 6, okay? So sine is opposite H over the hypotenuse. Okay. I like to make these proportions, cross multiply, and basically you're dividing by 1. That's not going to do anything. So I'm going to take 6 times the sine of what, 70? And then again, technically I'm dividing by 1, but that doesn't do anything. All right. So I get 5.64 for the height. Okay, so this height is 5.64. And if you're like, well, Julie, how does that help you? Well, I do remember that a triangle has a formula half base times height for area because it's half of a rectangle, it's half of a parallelogram. And so I'm like, oh, I know that formula. It's half base times height. And I happen to know the base of this triangle is 3. And I know the height I just got was, what is it, 5.64? 5.64. All right. And if I type that in my calculator, all right, I get that same 8.5. And you can see that if I show the numbers here, this is half, this is 3. How did we get the 5.64? Well, we took the 6 times the sign. Okay, and you can see that's exactly what we typed in. So this proof is not that big of a deal because really what they do is they cut it into a right triangle, they solve for the altitude using sine, and then they just kind of go back, sub things in and get this formula. It's not that challenging of a proof. But if you're stuck, remember, you can get by without law of sines and cosines. You just have to cut right triangles and know your trig and know Pythagorean theorem and know other things, okay? All right, so let's go back to Heron's formula. So, well, let's go back to this guy. Happen if you forget both of these. You're like, I don't remember this, I don't remember this, but oh my gosh, I do remember Heron's. Well, remember, we solved this triangle using law of cosines, right? And we got C to equal about what, 5.717 before rounding. So could you use Heron's on this? Yes. Now, this is a rounded number. So if you use Heron's, it's probably going to be off a little bit, right? Okay, it's going to be off a little bit, but you know, you could do it. Same thing with Heron's formula. If you're like, well, I forgot how to do Heron's. Well, remember we did law of cosines on that guy too, right? We did this. So, you know, you could do the half BC times sine of A, angle A, if you want to on this. But again, rounding can cause you some issues. So you got to be a little bit careful on that. All right. Story problems on these type of situations. All right, let's think about this. It could be that you maybe want to find the area of some weird shape, you know, so you might have some weird quadrilateral here. And so if you have this weird quadrilateral and maybe you don't know any of the angles, okay? So then what you could do is, you know, if you have it cut here, right, and you know that distance, if you know these 3 distances, you could do Heron's on that to get the area of that. And then if you know these 3 side lengths, you could do Heron's on that one and then add them up to get the total area. So you could find the area of some weird shape by cutting it into triangles that are not right triangles. And if you know 3 sides, you do not need to know any angles. You could use Heron's, okay? Or maybe vice versa. Maybe you know this angle, you know, so maybe they tell you this is, say, 70 degrees. Maybe they tell you this is 65 degrees or something like that. Maybe they don't tell you this side, okay? You don't have right triangles, so, you know, you can't do Pythagorean theorem there, but maybe you could do law of sines or law of cosines, right? If it's side angle side, looks like a great law of cosines problem if you want to get the side. But otherwise, you could do the half formula. You could do this one, because if you know these 2 sides with the angle trapped between, you could get the area of this triangle, the area of that triangle, and then, you know, add the 2 up, okay? As far as law of cosines, law of sine problems, again, things that are not right triangles, right? So you could have like 2 people walking and then they walk apart from each other, okay? So maybe they walk apart at a 110-degree angle. You know, maybe one person walks a distance of 3 miles in that direction. Maybe the other person walks 4 miles in that direction, and you want to know how far apart those 2 people are, right? You could do law of cosines on a problem like that. Or, you know, given if they give you different information, you could maybe do law of sines. It just depends on what they give you, okay? So things that don't have right triangles, those tend to be law of sines, law of cosines. And then for area, if you know side, 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 you do Heron's. And if you don't know, if you know side, angle, side, then you do the half, the 2 sides with the angle trapped between, the sine of the angle that's trapped in between them. All right, hopefully that helps. If you need more videos, let me know. If I make mistakes, yell at me. Let me know in the comments and I can delete and remake because I'm trying to get a lot of these done. So sometimes I rush, I make dumb mistakes. So, all right, take care. Have a great day.